Okay, 35. We got a dock worker loading crates on a ship. He's got a 20-kilogram crate initially at rest on a horizontal surface. Requires a 75 Newton horizontal force to set it in motion. Okay, 75 newtons of force to set it in motion. So let's set up the free body diagram. Now this is kind of like a two-part question. So the first thing they tell us is the force required to set it in motion. Then the second part, it says once the crate is in motion, a horizontal force of 60 newtons is required to keep it moving with a constant speed. So what they're asking us to solve for here, they want the coefficient of static and the coefficient of kinetic friction. So that's mu sub s equals question mark, mu sub k equals question mark. So what's the s? Static. What does static mean? Not moving. K, kinetic, which refers to moving. All right, now what's the equation for friction? Friction is coefficient times normal force. Is this equation true for both types of friction? Yeah, it's true for static friction. It's true for kinetic friction. You know, the thing to know about friction, as we said, once you overcome the static friction, the kinetic friction is always less. You know that from just being alive. So this guy pushes on this box here. Now look, 75 newtons, when this applied force here is 75 newtons, that's when the box starts to move. So what about when the force was like 70 newtons before it got to 75? What's happening there? Nothing. It's not moving yet. How about when the force was like 50 newtons? What was happening? Nothing. The magic number is 75 newtons. That is the force needed to overcome the static friction. You can almost think of it like this. If you plot force, like if you're trying to move an object, the force builds. Now what happens when it's like right here would be the 75. What happens when you reach the 75 newtons? The force required drops, and then you're into the kinetic, right? So this is like kinetic right here. This is the kinetic friction, and then right here is the maximum static friction. Does that make sense? Okay, so let's solve this problem. It's actually a really quick problem. Okay, so we're not done with the free body diagram. So what are the forces? So we're starting here with static. This is the box not moving. Okay, static. What are the forces? So we have the applied force of 75 newtons. What else is in the horizontal? Friction is pointing back. That's our static friction. Mu static times normal force. All right, what else do we got? mg down, normal force up, like that. Okay, so that's the sum. That's the free body diagram. So now we sum the forces. So we sum the forces x, we sum the forces y. Okay, and make sure you pay attention to sign convention. Plus, minus, like that. Okay, so what are the forces in the x direction? We have 75 newtons minus mu static times normal force. Those are the x forces. What is the sum of the forces always equal? ma. Now, is there an acceleration here? No, because 75 newtons, that's the force that sets the box into motion. Okay, so what we're going to do is we're going to say, in fact, I guess to be super thorough, instead of this being 75, set it equal to 74.999999 newtons, right? In other words, is the box moving yet? No, the box is not moving yet. So that acceleration goes to 0 because the box is not in motion. So we can erase this and put in 0. Okay, y direction. We have normal force up, mg down, sum of the forces equals ma. where that's a y acceleration. Is there a y acceleration? Does the box accelerate this way? No. So this A, the y acceleration goes to 0. And now we can solve the problem. So look, what's the normal force going to be equal to? mg. So when you plug in m is 20, gravity's 9.8. This is 196, I think. Is that right? So the normal force is 196. Now we can solve for what? Mu static, right? They're asking for what's the coefficient of static friction. So mu static is going to be 75 newtons over the normal force, and then the normal force is 196. So this is going to be 75 newtons over 196, and this gives us a mu static equal to 0.383. Boom! You guys get it? Okay, so then the second part of the problem, they tell us that once the crate is in motion, the force required is 60 newtons to keep it moving with a constant speed. Hey man, what are they telling you here with these words? Constant speed. If something moves with a constant speed, the acceleration is 0. So pretty much it's the exact same setup, but instead of this being 75, it's now 60, right? And instead of this being friction static, erase the S and replace it with K. Oh, I'll change this here. This is now kinetic, meaning in motion. Okay, so it's the exact same setup, only the force changes. Less force is required to keep an object in motion. More force is required to overcome the friction. So just replace the 75 with 60. Did the normal force change? Nope. Normal force is still the same. So now it's going to be 60 over 196. So this gives us a mu k of 0.306. So those are the answers. Mu static is 0.38. Mu k is 0.306. The free body diagram is identical for static and kinetic. The only difference is, the 75 changed to 60, and then the S changed to K. Other than that, it's the same.